Okay, we'll get started. In this section, we're going to be looking at 9E, which is light and color is the topic. So the first thing is to talk about white light. So white light is a light that is composed of a continuous spectrum of colors from red to violet. So if you were to look at white light, it looks just one color, but what it really is it's broken up into many colors: red, green, orange, blue, violet. Right? There's a lot of different colors that make it up, but together they're going to look white. So you can make white light by just the three primary colors technically. So that would be red, blue, and green. So featured right here, red, blue, green. So those would be the primary colors. And when we see things a certain color, that's because of the colors of light it reflects. So if we see like a red apple, sure. So what's happening is this white light that's hitting it, most light, like light from the sun, is going to be white, and it hits the apple, and what's happening is most of those colors are getting absorbed, and then really it's just red that's getting reflected, and that's what your eye is seeing, is that red light, and that's why the object looks red. So again, if you see things a certain color, it's because of the colors of light it reflects. And it could be more than one, it could just be one color. So if you take those primary colors of light up here and you mix them, you're going to get the secondary colors. So the first secondary color would be yellow, yellow light, yellow, right here, yellow. And that's going to be made up of red light and green light. It's a combination of those two primary colors. The next type of light would be magenta, magenta light, and that's going to be made up of blue and red light. And magenta looks like this right here. This would be magenta. It's kind of a purplish color. And then the last secondary color is cyan, C-Y-A-N, cyan. That's made up of blue light and green light put together. So this would be cyan right here. It's kind of like a lightish blue. So those are all the secondary colors, and those are all made by mixing the primary colors, red, green, and blue. All right, the next section is something kind of an application of these. So there's pigments. Pigments. And what pigments are they're chemicals that reflect or absorb certain colors of light. So when you, like if you had like red pigment, basically you're going to see, let's say this red pigment, that's what you had. What you're going to really see is that's a specific chemical that's designed to just reflect red light. Red light. And then everything else is going to be absorbed, basically. So again, that's the focus with the pigment, is it's going to reflect a certain number of colors and then absorb the rest. And you use pigments because you want to color stuff a certain color. A lot of times the natural color of something is not what you want, so you add pigments to it. And these chemicals are going to make the color exactly what you want it to be. So again, you can mix pigments, and when you mix pigments, only colors that both pigments have are going to be reflected, basically. So I'll give you an example. So if you mix yellow pigment and magenta pigment, yellow and magenta, yellow pigment reflects red light. If we look up here, red light and green light. And then we have magenta pigment is going to reflect red light and blue light. So again, they both reflect red. So what's going to happen is you're going to get red light. So if you mix yellow pigment, magenta pigment, you're going to see red light being reflected. And again, that's basically, you effectively have red pigment then. And it's the same thing with yellow and cyan. Yellow reflects red and green, cyan reflects blue and green, so they both share green. They both reflect green between them. So you'd see this as green light, and you effectively would have a green pigment. And then the same thing for magenta and cyan. They both, the color they have in common, the primary color, is blue, so you'd effectively have blue pigment. You'd see blue light if you mix these two. So that's really it with pigments. Last thing, a couple things to keep in mind. White light is created when when no colors of light are absorbed and all are reflected. So if you have an object and literally everything that hits it bounces off, this would appear white. But if instead you had an object where you have all the colors hitting it and nothing is absorbed, or sorry, everything absorbed, you'd see black. See black light, or it's just no light effectively. So again, white is, you see white if all the colors are reflected, you see black if none are reflected. So all are reflected with white, none affected with black light, or just black, basically. It's not, I guess you could technically say black light, or you can no light, basically. Okay, that's it for the notes. So what white light is, the three primary colors, the secondary colors, pigments, and how you can mix them, and then just a reminder about what white is, what black really is. Okay, we're going to do a problem out now with this. 1 second. Here we go. So this is a problem, something you're going to see. This is kind of an introductory problem to this all this color stuff. So take a second, make sure you're actually solving it out. So solving it out, you're not playing Fruit Ninja. Okay. So it's asking what primary colors of light will be reflected by each pigment. So the first one's fairly straightforward. So if you have red pigment, that's just reflecting red light, because red light's a primary color. So A is just red pigment, red light. Very similar with B. Green pigment, you're going to reflect green light. That's a primary color. Green light. C, it's a little bit more complicated. If we remember magenta, magenta is really made up of red light and blue light. So you'd have both of those basically. So magenta would reflect red and it would reflect blue light. So it's really reflecting both of those if you had magenta pigment. Very similar with yellow pigment. Yellow pigment's a secondary color, so yellow pigment is really, you're reflecting two things. You're reflecting red light and you're reflecting green light. So if you reflect both of those, that's why you'd see yellow, basically. So if you have yellow pigment, you're really reflecting two different types of light. And then the last one, magenta and cyan pigment. This is probably the most tricky one. Remember, if you're mixing pigments, then to figure out what would come out, what type of light would ultimately result, you have to see what types of light each one reflects. And then the one that they both reflect is going to be what's produced ultimately. So if we have magenta, that is red light and blue light. And then if we have cyan, that's going to be blue light and green light. So the one that they have in common would be blue. They both reflect blue. So if you mix these colors, or these pigments, you effectively get blue pigment, or this is going to be, this will come out to be blue light. So that's the idea. There's not a whole lot to this. You just got to be careful with thinking about the secondary colors and what types of light are making them up. So make sure you have this all down, and that's it for now.